Alright, so now we're going to take a look at some different array algorithms as well as some operations for comparing arrays. So to get into some of these array algorithms, we're first going to look at how we can go about using an array or taking the different elements of an array. We're going to add those together to get a total of all of the items inside of that array. So the sum of the elements of a numeric array can be calculated by simply iterating over the array and adding each element to a running total. So in this particular example that we have right here, we're going to initialize a total to 0. So we have that int total equals 0, since obviously before we've started counting any of the items, our total should start at 0. We're going to add each element of the array to our total. So again, we're going to assume that we have some kind of array called numbers. We'll go ahead and add each one of the different items. So we're using a for each loop to do this, saying for int number in our numbers array. We're going to go ahead and take that total and we will add to that one of our numbers. So we can accomplish this with a combined assignment operator, where essentially we have whatever our current value for total is. We'll add the number that we're currently looking at to that total, and then we'll take that sum and store that back into total. So let's go ahead and put together a program to at least get that much set up. So go ahead and minimize that, come over to NetBeans. Go ahead and create a new project. So I'm going to go ahead and make a new Java application. Click Next. For this one, I'll go ahead and call this one Array Algorithms, since I'm going to be using this for a few other things besides just this sum. Go ahead and click Finish. So we'll go ahead and remove the extra couple of comments and adjust the style of this a little bit. And then inside of the main method right here, we'll go ahead and start off by creating that int array. So we're going to go ahead and declare an array called numbers, and we're going to assign to it some array. We'll go ahead and just give it some array with some initialized items inside of it. For this one, since we're going to do it with a sum, I'll do something pretty simple. We'll just do the numbers 1 through 5. So do 1, 2, 3, 4, and 5. We also need to make sure that we have that running total. So we're going to go ahead and do an int, call it total equal to 0. And then the next thing I need to do is to go ahead and set up my for each loop, or my enhanced for loop. So we're going to have for int number in numbers. For this, I want to go ahead and do two things with this. I want to go ahead and show what the current total happens to be, as well as actually doing the addition, or actually calculating what that total happens to be. So we'll go ahead and do the sum first. So we're going to do total. I'll show this in its complete form first, and then we'll change it with the combined assignment operator, just so we understand what's going on here. So we're going to say total equals total plus number. We're taking whatever the current value for total happens to be. We're adding this number to it, so each one of the different items in the array. And then we're going to go ahead and store that sum that we get by adding those two numbers together back into total. So initially, total is going to have the value 0 plus number. So it's going to be the first one right here, which is 1. We'll add those together, get 1, and then assign that to, or store that into total. On the next iteration of this for loop, so we go back around, we get the next number right here. So we're going to get 2. Our total now currently has the value 1 inside of it from the previous iteration. So we're going to do 1 plus 2. That'll give us 3. So we'll go ahead and take that sum of 3, put that back into total, move on to the next iteration. So we'll go to the next number, which in this case is also 3. So we're going to have 3 for our number, 3 for our total from the previous iteration. Add those together and get 6. We'll go ahead and store that back into total. And then we're going to repeat this process for 4 and 5. So we're going to do 6 plus 4. That'll give us 10. And then we'll do 10 plus 5. That'll give us 15. So that's going to give you the set of different numbers that we should expect to see printing to the console as we step through these different iterations of our for loop. So we do system.out.println. And right here, we'll go ahead and put total. I will also go ahead and modify this now to just use the combined assignment operator to keep the code as concise as possible. So we're going to do plus equals instead. So we'll go ahead and save that. And so then if I go ahead and run this, it will start off with the very first sum, so the very first total that I'm getting by just adding this first number. So it's going to give me 1 to begin with. and then from there it'll continue to give me the numbers being added together. So it'll do 1, then 3, then 6, and then 10, and then 15. So if we go ahead and run this, we can see each one of those numbers here. We have 1, 3, 6, 10, and 15. All right. So in addition to this, once we've got our sum by adding all of the numbers together like this, we can also get the average of those numbers by simply dividing the total, so that amount that we just got from the previous couple of steps, we can divide that by the length of the array. So essentially we're just going to take all of the items that we have their sum, and we'll divide that by the amount of items that we have, the length of the array. So I have an example right here where we do that. One of the things to note is that the total that we're getting from this is an int, and the length of an array is also going to be an int. So if we do this division, this would just be integer division. So to make sure that we actually get the decimal portion in our average, just in case there is a decimal portion, we're going to go ahead and make sure that we cast one of these to a double. So you can see the cast operator right there. And then when we store this into a variable, say like this average variable, we're going to go ahead and make sure that that variable is also of type double. So go ahead and minimize this. Come over here. So we're going to go ahead and create our variable. We'll call it average. Make sure that it's of type double. So it's going to be of data type right there. This is going to be equal to, so first I'll go ahead and write this out without the cast operator. So essentially we're going to be saying something like total divided by our numbers dot length. So this is what we're going to want. We want to store that into average. But if we go ahead and take a quick look at this, so for this one, we'll go ahead and print out that average. So if we run this, so we've got our 5 numbers right here. After that, we're going to see average at the very end. So right now, that's going to give us 3.0. So in this particular example, thankfully with the way that this is set up, we're not going to lose anything since it's going to be doing 15 divided by 5. Let's say that we add one more number to this. Go ahead and save that. So now if we do this, we're going to take this 15, we'll add this one last number to it, and it's going to give us 21. So we're going to do 21 divided by 6. 6 does not go evenly into 21, but if we run this, we see that we still get 3.0, so there seems to be a bit of a mistake here. So that's where the cast operator becomes important. So we want to make sure that we go ahead and cast at least one of these ints to a double, so that then when we perform this division, we'll perform it as double division instead of integer division. So now whenever we check for our average right here, we can actually get the decimal portion. So now we get 3.5, which makes a little bit more sense. All right, so in addition to being able to calculate the sum and the average of our items, we can also take a moment to look through or kind of comb through our arrays to try to pick out particular values that we're actually interested in. So we can get the highest value in an array by first assuming that the value is at position 0, and then stepping through the array to check for anything that would make that assumption false, and just updating what our assumption about the highest value happens to be. So from here, we're going to iterate over the array, and comparisons are going to be made to the individual elements. If a value is higher than the assumed highest value, then our assumption is going to be updated. So initially, we're going to assume that position 0 holds the highest value. So we've got this integer variable that we call highest. That's going to be equal to the value at position 0 of numbers. So we have number 0 right there. We're going to then iterate over the array starting from position 1. So we don't need to start from position 0 since we already have that accounted for. So we're going to start from position 1 and then keep going until we get to the end of the array. So keep going until for as long as index is less than numbers.length, making sure that we increment the index each time we step through this for loop. So if a number is found to be higher than our highest, then we're going to go ahead and update the value of highest to be that number instead. So we're going to say if the number that we have at this particular index is greater than highest, we're going to go ahead and say that highest is equal to whatever that number is that we just found. So in addition to this, I'm going to go ahead and cover the next part as well, which is that the lowest value in an array can be determined by following the same assumptions. So we're going to go through the same general logic. We'll make the same comparisons as the highest value. Everything is just kind of inverted. So now we're going to start by assuming that the lowest value is at position 0. And then if we find something that's even lower than that, somewhere in our array, then we want to go ahead and update our assumption about what the lowest value happens to be. So I'll go ahead and put this together. We'll start by creating the logic for just one of these. So we'll start with just the highest, and then I'll kind of modify that logic to also include the lowest. So go ahead and minimize this, come back over to NetBeans. And so then, after setting up all this code right here, let's go ahead and just move to the next part. So for this next part, what I want to go ahead and do, just to kind of make this a bit more interesting, I'm going to go ahead and kind of scramble these numbers around. We're still going to use the numbers 1 through 6. I'm just going to kind of rearrange the order. So we'll do something like 1, 6, 3, 2, 5, and 4. And I guess to also keep that interesting, we'll keep the 1 in a different position as well. So we'll do something like this. We'll have 5, 6, 3, 2, 1, 4. Okay. So the highest value in this array is this 6. We're going to find that at position 1, starting from 0. And then the lowest value is going to be this 1. That's going to be at position 5, or 4. So position 4 of this array. Okay, so what we want to go ahead and do is first make the assumption that this value right here has our highest. So we'll go ahead and do just that much first. So we're going to say int highest is going to be equal to our numbers at position 0. So obviously, if we take a look at this, we immediately recognize that this assumption is going to be wrong. The highest value is actually going to be the 6. But of course, we can't really just immediately jump to that conclusion. We need to let the computer step through every one of the items to be able to determine that that is in fact correct. So we'll go ahead and create our for loop right here. So we're going to do something like for int index equal to 1. So we're going to start from this position right here, since the 5 at position 0 is already accounted for with this initial setup. And we're going to say index less than our numbers dot length, and then index plus plus. And then inside of here, we're going to have our if statement. So we're just going to have a single condition where we're saying if the number that we're currently looking at, so the number at whatever index we're currently at, if that is greater than highest, then that tells us that our assumption is wrong. So we want to go ahead and fix that or update our assumption about what the highest number is. So we're going to say if numbers at index is greater than highest, then we want to go ahead and take whatever that value happens to be and assign that to highest. So we're going to say highest equals numbers index. And then once we've completed all of this, if we go ahead and try to print out highest to the console, so we'll do system.out.println and put highest right here. Go ahead and save that. So now the expectation is that the very last print statement is going to print out the 6 because that is the highest number in this array. So we'll go ahead and run this, and we can see right here we're getting that 6 at the very end of this. So then in addition to this, we'll go ahead and make a slight modification to also include lowest. So coming back up here, we'll go ahead and do int lowest. This one's also going to start from position 0, so we'll do numbers 0. So again, we're going to start by assuming that this 5 is the lowest amount. And again, we can tell just by immediately looking at this array that that assumption is wrong. This 1 near the end here, that's obviously going to be the lowest value. But again, the computer doesn't immediately recognize this. Instead, we have to allow it to step through the entire array to make all of these comparisons to determine that that is in fact the lowest value. So right here, in addition to this logic to find the highest value, I'll go ahead and add in the logic for finding the lowest value. So we're going to say if the number that we're currently looking at, so numbers index, if that is less than our lowest, so it's even smaller than what we assumed the lowest to be, then we want to go ahead and update lowest with this new assumption. So we're going to say lowest is equal to numbers index. Go ahead and save that. And so then for this one, we can go ahead and print that out to the console at the very end, and we should expect to see the value 1 for this. and save that. And so then if we go ahead and run this, so we got 6 for our highest and 1 for our lowest. Okay, so this will give us all the logic for identifying the highest or the lowest value inside of an array. Okay, so the next thing we're going to take a look at now is how to actually compare two of our arrays to see if they are equal or equivalent to each other. So in order to determine if two arrays are equal, you must check both the lengths of the arrays as well as the individual elements of those arrays. So obviously the first thing we want to take a look at is whether or not the individual items of those arrays, or the number of items in those arrays, that's equivalent, because if it's not, then we immediately recognize that the arrays can't be equal to each other, so that kind of saves us some additional processing, so it's more efficient that way. But if they do have the same size, then we want to go ahead and start stepping through the individual items to check if all of the different pairs that we're comparing, if those are all equal to each other. So in this following code, we start by assuming that the arrays are equal, and then this condition is going to be continuously checked in this while loop that we have. And as soon as it is determined that the arrays are not equal, we can immediately terminate this loop. So initially, we've got this Boolean arrays equal set to true. We're then going to have this first condition that we check saying if the lengths of the two arrays are not equal to each other, we want to go ahead and change arrays equal to false. That way then when we get to our while loop, part of the condition of that while loop is assuming that arrays equal is still true. But if that immediately became false because they don't have the same length, then we're just going to skip the entire while loop. So it saves us a little bit of processing time. If, however, they do have the same length, we're going to go ahead and start stepping through this while loop. So this while loop has two different conditions that we want to keep track of. The first is that the two arrays are equal to each other, and then the other thing is going to be making sure that our index is always less than the length of the arrays. So essentially that part of the condition is the same as what we saw for our for loops. So basically saying that we're going to stop this while loop once we've reached the end of our arrays because we're done comparing them. And so inside the body of that while loop, we're going to just have a single condition that we need to check for, which is basically just saying if the item at the same position in both our first and second array, if at any point those items are not equal to each other, then we're going to go ahead and change the arrays equal Boolean to be false. And then the other thing we're going to go ahead and do is make sure that we update our index. That way then we at least have some way to terminate this if they're actually equal to each other. So we'll go ahead and minimize this. So for this particular program, I'm going to go ahead and create a new Java project. So we'll go ahead and make another one. So I have another Java application. Click Next. For this particular one, we'll go ahead and call this Array Comparisons. And click Finish. I'll go ahead and remove some of the extra comments that I'm not going to need. And then inside of the main method, the first thing I need to do is go ahead and set up two different arrays so we can compare them in a moment. So let's go ahead and say we have some int array. We'll go ahead and use the same naming conventions as what was presented in that example. So we'll do first array. And for this first one, let's go ahead and just do the numbers 1 through 5 again. We'll just do 1, 2, 3, 4, 5. And then initially, I'll go ahead and set this up, assuming that both of these arrays would be equal. So I'll go ahead and create a second array. Say this is equal to those same values, 1, 2, 3, 4, 5. And then the last thing I'm going to need here is going to be my Boolean variable, saying the arrays are equal. So say arrays equal, going to be initially set to true. The first thing I'm going to check is if the lengths of these two arrays are equivalent to each other, or more specifically, I'm going to check to see if they're not equal to each other. If they're not equal to each other, we're going to go ahead and change arrays equal to be false. So say if first array dot length does not equal second array dot length. We'll go ahead and just say that our array is equal, should be false. That way then we don't have to worry about executing anything in this while loop. But assuming that they are equal, so this doesn't change to false, we'll go ahead and start going through this while loop. So inside of this, we're going to be checking if the arrays are equal, and we're also going to be checking to see if the index, so in a moment I need to go ahead and declare that variable as well. We're going to be saying if this index is less than, at this point we're assuming that they have the same length, so it wouldn't really matter which one we use. Let's say we just use first array's length. So then we'll go ahead and set out the body of this, but first we're going to go ahead and make sure we actually have this int for index. So if we're using a variable for the index, again it's going to be just like our for loops whenever we're iterating over the items or the elements of an array. So we want to make sure this is initialized to 0. So we're going to start from the 0th position of these arrays and then step through every single item to make sure that they're all equal to each other. So essentially what's going to happen is we first start at position 0, so we're comparing this value and this value. We want to make sure that those are equal to each other. We then step to the next one, so we're going to go ahead and check this value and this value, make sure that those are equal to each other. Then we step to the next one, so we're going to make sure this value and this value are equal to each other. And then we're just going to keep repeating that process until we either find a pair of values like this that are not equal to each other, or we reach the end of the arrays. So we'll say if taking first array at the position of index, that is not equal to our second array at that same position index. Then we want to go ahead and change our Boolean. So we've got array is equal, should now become false. And then in addition to this, we want to increment our index so that we eventually terminate or break out of this while loop. And so then once we've gone through all this, what we can go ahead and do at the very end here to check to see whether or not this ended up being true or false, we can go ahead and print something to the console. So I'll go ahead and just include a little thing right here saying if array is equal. So if this Boolean is still true, then that tells us that the arrays are equal. So we'll just go ahead and print that to the console. Say the arrays are equal. Otherwise, we'll just go ahead and print the arrays are not equal. Go ahead and save that. And so then if I go ahead and run this, what's going to happen is we're going to take these two arrays, first array and second array. We'll check their lengths. Those are going to be equal, so this will stay true. We'll come over into this while loop and step through the items. So we can see going through this, we have 1, 2, 3, 4, and 5. So all of those elements are the same in both arrays. So this will also, arrays equal will also stay true throughout all of this. And so when we get to the very end, we'll just go ahead and print out the arrays are equal. So we go ahead and run that. We can see right here, the arrays are equal. And so then if we go ahead and start changing some things in these, say, for example, we change the length. So now what's going to happen is as soon as we check this condition right here, we're going to say that first array's length is not equal to second array's length. So we're going to go ahead and execute this line, change arrays equal to be false. So because it's false right here in this while loop, we're not going to execute any of that. We can immediately come down to our if else for our final print statements. And in this case, we're going to go ahead and print out the other statement, which is going to be that the arrays are not equal. So we go ahead and run this. We see the arrays are not equal. And then the other thing we could do is if the contents are not the same. So maybe we do something like this. So this example would be what we would describe as the worst case scenario, where we're going to go through all of the processing. We get all the way to the very last item in the two arrays. So we had to go completely through this while loop, only to find at the very end that the two arrays are not equal to each other. So this is going to have to go through all of the same processing as if they were equal to each other, with just one little difference at the very end. So if we do this one, again, we run into the same as the previous example. So in this case, the arrays are also not going to be equal because of the fact that the last pair, this pair right here, those are not equal to each other. So this line is going to end up executing, changing arrays equal to be false. So we go ahead and run that. And again, we're going to see that the arrays are not equal. Okay. So one last thing that I want to take a moment to just kind of briefly discuss without really writing any code for this is going to be dealing with partially filled arrays. So this is talking about arrays where you've provided some initial values for some items of the array, but you've not done that for every item or every position of the array. So some of those positions are either still initialized to 0, or if you're dealing with something other than numeric values, as we'll see in a little bit, they might be initially null, which is one of the worst case scenarios for that, because if you try to operate on something that's null, there are a lot of different instances where that's just going to give you errors in your program. So we need a very effective way to address or deal with partially filled arrays. There are 2 recommendations for the design approach. One of those is to set the array size to the highest expected number of elements. This eliminates the need for additional space beyond the bounds of the array, which cannot be modified after its initial construction. So what this one's going to do is essentially you will create some final variable, so some constant that you have. You can set that to whatever the max value is, so the maximum possible number of items that you're going to put into the array. And then, in addition to this, you want to go ahead and keep a count of the number of filled elements in the array. This is going to be useful for iterating over the array without accidentally including any of the unfilled or unused indices. So in this particular example, we're going to say that we have some variable called current position, or just shortened to curpos, that's going to keep track of whatever the highest position that we're currently working with happens to be. We're assigning some value to this numbers array at that position, and then we're also going to increment, kind of update that current position, so that way then when we need to use this in one of our for loops, what we can go ahead and do is just use a traditional for loop, and we're essentially going to say that as long as our index is less than whatever this current position is, that helps to make sure that we don't accidentally start going into parts of our array that we have not yet initialized or filled with meaningful values. All right, so at this point, this is going to wrap up everything for some of these array algorithms and being able to compare arrays. In the next video, I want to go ahead and take a look at the other half of dealing with arrays in methods, which is just briefly addressing how we return arrays from our methods.